it kind of like solves the problem of having to like worry about privacy, like where like you don't have to just send your code, your proprietary code to like a bunch of miners you don't trust. If you want, you can actually run the code yourself and use the agents on your own. But yeah, that's kind of the incentive right now, where we're moving from basically this model of the validator asks the miner a question, the miner sends back some code, and then the validator evaluates it on a bunch of different criteria, and then like basically ranks the miners and gives most of the rewards to the top few miners, to like a new one where like the miners upload all their code to like a public registry, and then the validators can then run that code themselves and evaluate it for themselves. There's also like another big difference in that like we're splitting it up. So before it was like there's like one type of problem, which is just like the validator generates some very broad problem, and the miner agent has to be able to solve any kind of problem like this. Um, Let me know if I'm kind of like rambling on too much, but like we're kind of moving to like a different model where like we want the miners to focus on a very narrow part of software engineering. The reason for this is that like I think like software, like the writing is on the walls. LLMs are very clearly good enough to write code. The software engineering and how you actually get there is not just about writing the code. There's like a lot of like small steps that software engineers have to do. It's about like kind of like thinking about the problem, figuring out what to do, kind of looking around. Usually you'll be wrong, so you have to like backtrack. It's very like iterative. Like you have to do like a little step. You'll edit some code, you'll see what happens. You'll edit some more code based on that. It's almost like a very feedback loop kind of thing. It's hard to build an autonomous software agent end to end that can do all the little things in a row reliably. Like it's like a common thing where like let's say you have like a 90% chance that your model gets it right, but now you're doing like 100 steps. By the end, the odds that your model actually got it right end to end is almost zero. But so what we want to do is we want to basically split each step up and get the miners to like specialize in one kind of step. So either like writing the code, or for example, like finding where in the code base they should edit, and getting really, really good at that. So kind of improve the probability from 90% to like 100% in that one step. And then we basically create like a handoff layer where like when someone gives us a problem, we can split it up into all these steps and allow the agents to just focus on their one step and hand it to the next agent to do really well. Which I think Bittensor is like in a really good position to do, because of like you can set up like an incentive where like you're evaluating on a very narrow criteria and giving emissions for that.
And how do these miners know which step to solve for? Do you just give them a whole code base and then they just pick one thing, or do you tell them a specific thing you want fixed or changed? How does that work?
So we'll specify like a bunch of separate incentive mechanisms within our broader incentive mechanisms, almost like a subnet, where we'll give them like they can basically choose what kind of agent they want to build, and then validators will generate problems specifically focused on that one type of agent. So for example, one of them is like context solution. So we'll basically define the agent type, and a miner can register an agent as a type of agent and then get problems for that problem type and just solve that problem type by itself. Tasks. Hard tasks are software engineering tasks that are very defined and very like you can very accurately measure whether the agent got it right. So an example of this is like context selection. You have a problem, you know where the agent's supposed to go to solve it. The only thing the agent has to tell you is where in the code base to go solve it. So now basically like they'll tell you, okay, you should go here in the code base, and you can just tell, are they roughly in the right part of the code base? Have they found the right files? Have they found the right functions within the right files? And have they found the right lines within the files of code? And so basically like there you can very precisely evaluate it. And there's a lot of kind of tasks like this that we want to start with. For what we kind of build our evaluation loops on, because we can very clearly measure whether they got it right. So I think for those it'll be pretty easy to get started. The harder ones are software tasks. Those are things like writing code, where like you can for example create tests to test the code that an agent has written, but it's much more difficult to objectively say whether one piece of code is better than another without an actual experienced human software engineer looking at it. As in like you don't want to just rely on a model saying this is better than this. There has to be like some rigorous way to check. And so the thinking on this is twofold. One is that you can build a semi-good pipeline for this just to get people developing agents in that direction and play kind of like a cat and mouse game of like catching exploits that come up. The other is that when you have all these hard agents that are very good and obviously like evaluated to be very good in a reliable way, you can start taking in bigger problems and let people also have agents that solve the soft part of it. So say, for example, someone comes to you with like a website, or they want an edit to their website and they're willing to pay $5,000 for it, just hypothetically, right? You may hire like an orchestrator agent that their only job is to find other agents that they can pay to get the job done together, because that agent is going to be like one person. They're not going to be able to solve, or like the whole point is that they don't solve it end to end. Instead, they kind of like piece all these agents together. And so they can obviously see what are the best agents for the harder tasks, because they can just select them based on their evaluated criteria. For the softer tasks, it's up to their discretion. And again, consider that they're competing for all these like basically contracts. So they'll basically pay these other softer agents and decide like that who they want to kind of use among the agents that are registered on the platform. So you end up basically creating like a market where if I am like an orchestrator and I'm trying to find the best agent to help me solve this problem, and it's like a bit of a softer task, I'll probably spend a lot more time looking at the agent outputs and choosing an agent that I can trust for the soft quality output. And so it's almost like let the free market decide for those, if that makes sense.
And that orchestration layer, is that does that fall on you as the subnet owner, or is that going to be a subnet that you put on miners as well?
I'm not 100% sure. I think we can go both ways. To be honest, I feel like just like this, like whatever we develop, owners will be better at it. So I think long term, it would be better for us to design an incentive that gets orchestrated models on it. And longer term, like there's going to be many kind of different tasks and many, many different agents. Right now, we're letting people register agents as miners, but I think long term, what you could do is the 256 miner slots or the 196 miner slots um, are just orchestrator slots. I don't think I've spent enough time here to comment on that properly. I think that like for sure things are going to change, and I think detail is really going to change the landscape of what kind of subnets do well. Beyond that, I don't know. It's not an honest
And
answer.
for detail, you have a interesting idea for rewarding miners extra incentive for outside revenue you guys bring in. Can you
Yes.
explain that idea?
Yeah, I mean, like, so fundamentally, when we build this platform, right, we'll have like a bunch of miners that are at the end of the day the ones contributing the agents, the ones improving the agents. And there's no real vendor lock-in. I mean, you kind of have like some moat in the sense that like when someone used their product, they don't want to switch. When something's embedded in someone's workflow, they don't want to switch. And that it is like a lot of like tooling to go from taking that agent, deploying it, using it in the right context. But beyond that, like there's no reason why a competitor couldn't form. And so it's like, I think one of the better ways to kind of keep that distribution strong is to and also like to be honest like the fair thing to do is to also give miners like a cut of the revenue that they're making. Unlike for example like Devin or Cursor or whatever, like we don't have a high overhead of building our own models. We don't have a high overhead of like R&D because we have like a ton of engineers doing research because that's what the miners are doing. And so it's only fair that those guys also get a cut of the money that they're making as a result. So it's like our overhead would be very low. It would basically be payroll of the underlying company, whatever little R&D we do internally, but that's most like incentive mechanism related R&D of like running benchmarks on miner output, stuff like that. And so the margin like that we would make, like Cursor is like what, 500 million ARR as of today, they announced. Our margin would probably be like way higher than them, like 80, 90% easily, maybe probably more. Like I can't imagine our costs would get that high. And so and so that margin can and should be allocated towards keeping that network strong, keeping like the foundation that allows that margin to come in the first place. Almost incentivized to stay there and want to kind of continue to be part of it, build it, even like catch exploits and like make sure the quality of agents overall is going out up outside of their own agents because it means more users for them, more revenue for them.
Do you have any, I hate to use the word flywheels, but tokenomics ideas besides just buybacks for the alpha token?
I did. And I got feedback from someone that's actually quite experienced with this that it eventually creates like a Ponzi situation, so I killed that. So yeah, other than that, not really. I mean, I think the biggest one is just drive revenue. Build a really good product and have miners get paid for actually for doing their product. Like do like a revenue share, and that problem kind of solves itself. Especially because then their costs are abated and they want to hold it because like the alpha token is almost like a stock. It's not a stock, but it's almost like something that represents your company. And so like they want a piece of that if the product is just getting better.
Yeah. Well,
I do.
Shakeel, no,
I do
no.
think that there is actually one very cool flywheel in the new incentive mechanism, though. In that, like, in the previous model, like if someone had like a dominant agent for a specific type of coding task, it's hard to compete as a new miner and get incentives because you can't see what they're doing to kind of get their agent to that point. And it's expensive to kind of do testing with agents. You're making like a lot of AI LLM calls, basically. It gets pricey. I think that like this new model where like everyone can see everyone else's code allows the competition itself to become like a flywheel, where like if I can see another miner's code, as soon as I, as a miner, publish the dominant code that everyone can see is scoring the best, the clock is ticking. Because someone else can take that code and run it themselves. The way we're setting it up right now is not that like, if you take someone else's code and run it yourself, you don't get rewards. But if you do take someone else's code and you improve it further, you do get rewards. And now, like, so basically, if I'm a miner and I publish the best agent code, and someone else basically sees that and improves it, and now I'm no longer the best miner. I basically have to constantly be on my toes and improving. And it creates like the situation where like it gets more and more intense competition, where like I think what's going to end up happening is that people are going to write agents to write agents instead of writing the agents themselves, because it eventually becomes too much competition too fast. Where like almost a better thing to do is to build an agent that can look at all the innovations that people are doing currently on the platform and also write further innovations on them. And it creates like a feedback loop where like now agents are competing with each other to write better agents, if that makes sense.
Okay. Where they they publish their agent code.
Mhm.
Is it winner take all in each niche or subsector? So like say you have context selection and unit
Yeah.
tests.
Yeah.
Would it just be one winner in each?
Much
Or
closer to
how
that,
does
yeah.
the distribution work?
Well, right now the distribution is kind of like fairly even with like the top miners getting a bit more, but not like 10 times more than the next best miner. I think you basically have an exponential model now where like you kind of want the very top cluster of models to be always be getting the bulk of the reward because everyone can see their code and so they can just take it and improve on that. And if they improve on it, that guy should get most of the reward, which then forces the previous miner to continually improve.
Is there some sort of decay function to where you're not just going to have one model that sits there for 3 months as the best model? Or
No, no. The decay function is that anyone can see the code, and if they can figure out a better way to implement it in that model or improve on that model, then they can do so and take your share.